Antarctica. It is a continent of extremes, a place where nature's harshest elements converge. It is the coldest place on Earth, with temperatures plunging to unimaginable lows. It is the windiest place on Earth, where fierce winds whip across the icy expanse. And it is the driest place on Earth, a paradoxical desert of ice. Today, Antarctica is covered in a massive sheet of ice, stretching as far as the eye can see. It is a vast frozen desert, a stark and silent wilderness. But it wasn't always this way. The land we see today hides a very different past. Millions of years ago, Antarctica was a very different place, teeming with life and greenery. Imagine a land covered in lush rainforests where the air was thick with humidity. This was Antarctica during the Cretaceous period, a time of incredible biodiversity. This period occurred roughly 145 to 66 million years ago, a blink in geological time. During this time, dinosaurs roamed the Earth, including the land that is now Antarctica. Antarctica was not located at the South Pole then. It was part of a supercontinent and situated much closer to the equator. It was much closer to the equator, basking in a warm and tropical climate. The climate was warm and humid, a stark contrast to the icy conditions we see today. Scientists have uncovered evidence of this incredible past, piecing together the story of a lost world. They discovered this evidence buried deep beneath the ice, preserved for millions of years. These discoveries tell a story of a lost world, a world that has transformed dramatically over eons. It is a world vastly different from the frozen landscape we know today, a testament to the Earth's ever-changing nature. This evidence helps us understand Earth's history, offering a glimpse into the planet's dynamic past. It also helps us understand the potential impact of climate change, reminding us of the delicate balance of our planet's ecosystems. Imagine finding a tiny droplet of amber. It is frozen in time. Inside, you see a perfectly preserved insect. This insect lived millions of years ago. This is not science fiction. This is the reality of scientific discoveries in Antarctica. Amber is fossilized tree resin. Trees produce resin to protect themselves from insects and disease. Sometimes insects or other small organisms get trapped in the sticky resin. Over millions of years, the resin hardens and turns into amber. Amber preserves these ancient life forms in exquisite detail. Scientists have found amber fragments in Antarctica. These fragments contain traces of ancient life. There are spores, pollen, and even tiny insects. These remains tell us that Antarctica was once covered in forests. These forests were home to a diverse array of life. Scientists use a powerful tool to study the past sediment cores. These cores are long cylinders of mud and rock. They are extracted from the ocean floor or from beneath the ice. They are like time capsules. They hold clues about Earth's history. In Antarctica, scientists have drilled deep into the seabed. They extracted sediment cores dating back millions of years. These cores contain layers of sediment. These layers built up over time. They trap the remains of plants and animals that lived in the past. Analysis of these sediment cores has revealed something astonishing. Scientists found evidence of ancient rainforests in Antarctica. They found pollen and spores from trees that could only have thrived in a warm, humid climate. These findings provided further evidence of Antarctica's tropical past. The Cretaceous period was a time of significant global warming. Levels of carbon dioxide in the atmosphere were much higher than they are today. This resulted in a greenhouse effect. The greenhouse effect trapped heat from the sun. This caused temperatures to rise around the world. Even polar regions experienced remarkably warm temperatures during this period. Antarctica, despite its polar location, was warm and ice-free. The continent was covered in lush vegetation. Rivers and swamps crisscrossed the land. Dinosaurs likely roamed the forests. The warm climate of the Cretaceous period allowed for the development of diverse ecosystems. Marine reptiles swam in the oceans. Pterosaurs soared through the skies. The Earth was a very different place than it is today. Section 5. Beneath the ice, a hidden landscape. Today, Antarctica is covered in a massive ice sheet. This ice sheet is up to 2 miles thick in places. It hides a remarkable landscape. Beneath the ice lie towering mountain ranges. There are vast plains and there are even active volcanoes. One of the most impressive features of this hidden landscape is the Gamburtsev Mountains. These mountains are as large as the European Alps. They are buried completely under the ice. Scientists use ice-penetrating radar to map this subglacial world. They are discovering a landscape that is more dynamic than previously imagined. This hidden landscape plays a crucial role in the stability of the ice sheet. It also influences the flow of ice into the surrounding ocean. Section 6, Mount Erebus, Antarctica's fiery heart of gold. Mount Erebus is a sight to behold. It is an active volcano. It is located on Ross Island in Antarctica. It is one of the few volcanoes on Earth with a persistent lava lake. But Mount Erebus holds another surprise gold. The volcano releases tiny gold particles into the atmosphere. This is a rare phenomenon. It is due to the unique geology of the volcano. The magma that feeds Mount Erebus contains small amounts of gold. As the magma rises to the surface, the gold is carried along with it. The gold particles released by Mount Erebus are minuscule. They are too small to be seen with the naked eye, but they are a testament to the incredible forces at work beneath the icy surface of Antarctica. Section 7. Life in the cold, dark, subglacial ecosystems. The subglacial environment of Antarctica may seem inhospitable to life. With its frigid temperatures and seemingly barren ice, it appears to be one of the most extreme places on Earth. It is dark, cold, and under immense pressure. The ice can be several kilometers thick, creating an environment that is both isolated and extreme. But even here, life finds a way. Microbial life forms known as extremophiles have adapted to these harsh conditions, thriving where few other organisms can. Scientists have discovered a network of rivers and lakes beneath the ice. These hidden waterways are like veins running through the frozen landscape. These waterways are home to a surprising variety of life. From tiny microorganisms to larger shrimp-like creatures, the biodiversity is astonishing. These subglacial lakes are unique environments. They are like time capsules, preserving ancient life forms and ecosystems. They have been isolated from the rest of the world for millions of years. This isolation has allowed life to evolve in ways that are vastly different from the surface world. The creatures that inhabit these lakes have adapted to survive in complete darkness and extreme pressure. Their unique adaptations offer insights into the resilience of life. One of the most well-known subglacial lakes is Lake Vostok. This massive lake lies beneath nearly 4 kilometers of ice. It is the largest subglacial lake in Antarctica. Its vast size and depth make it a focal point for scientific research. Scientists believe that studying the life forms in Lake Vostok and other subglacial environments could provide insights into the potential for life on other planets and moons. These extreme environments on Earth may hold the key to understanding how life could exist in the icy worlds of our solar system. Section 8. Climate change. Lessons from the past. Antarctica's journey through time provides a stark reminder of the power of climate change. The continent's transformation from a lush rainforest to a frozen desert highlights the dramatic impact that changes in Earth's climate can have. The evidence of Antarctica's past is a wake-up call. It tells us that the Earth's climate is not static. It can change dramatically over time. The rapid warming that occurred during the Cretaceous period is a reminder of the potential consequences of unchecked greenhouse gas emissions. By studying Antarctica's past, scientists can gain a better understanding of how the Earth's climate system works. This knowledge can help us predict and mitigate the effects of future climate change. Section 9. A window to the future. Antarctica's importance. Antarctica may seem like a distant and desolate place, a frozen wilderness at the bottom of the world, yet it is a continent of crucial importance to the entire planet, holding secrets that are vital to our understanding of Earth's climate. The massive ice sheet here plays a major role in regulating global sea levels, acting as a giant thermostat for the planet. It also influences ocean currents and global climate patterns, creating a ripple effect that impacts weather systems worldwide. As the planet warms due to climate change, the Antarctic ice sheet is melting at an alarming rate, releasing vast amounts of fresh water into the oceans. This melting ice is contributing to rising sea levels, which threaten coastal communities around the world, from small island nations to major cities. Antarctica is a barometer for the health of our planet, providing critical data that helps scientists understand the pace and impact of climate change. By studying Antarctica, we can learn more about the past, present, and future of our planet. uncovering clues locked in the ice for millions of years. We can gain a better understanding of the interconnectedness of Earth's systems, seeing how changes in one area can have far-reaching effects. And we can work to protect this fragile and vital continent for generations to come, ensuring that its unique ecosystem remains intact. Antarctica's story is a reminder that we are all connected, that the health of this remote region affects us all. What happens in one part of the world affects us all, highlighting the need for global cooperation in addressing climate change.